Right. Um, just testing the sound. Let me know if you can hear me. Okay, before I start. So, yeah, right. So I can also try and hear myself. 1, 2, 3, test. Just testing the sound. You can hear me. Okay, it's working. Okay. Welcome to another live stream. So I'm going to continue working on this Python project with Blender. I'm trying to visualize a neural network which was created in TensorFlow. And if you're curious about what that is, you just check the previous live streams. Like the beginning, I show always what I'm up to in terms of the overall project. But today, like the goal is to try and continue what I did yesterday, which was to I'm currently working in a specific layer, which is the fully connected layer. Okay, I think I have a warning here on YouTube telling me that my sound quality is not very good. It's saying that I should use something a bit better. So let me see if I can change that before I continue. Maybe for the next one it will probably be better, but so I have 2500 and it's telling me it should be 4500. Okay, right. Okay, right. Well, let's continue. So I'm just going to open this and I'll show you what I had yesterday. I mean, this is how far I got yesterday. This is supposed to be a fully connected 2 layers, right, of neurons, fully connected. The only problem I have right now is that, okay, this is a very simple example, right? I didn't put a lot of nodes, but we are supposed to have thousands of nodes or hundreds. And yeah, so this is going to, I have to make sure this function I'm creating is very efficient. Okay, so I have these artifacts. I'm not sure where they're coming from. Like I have these like sticks. They look like chopsticks, right? And yeah, I'm not sure where they're coming from. Okay, right. So what I need to figure out first is to make sure that I fix this. So let's go and have a look at the code. Okay, so we have the code from yesterday. Connect neurons. This is a function that takes 2 of those spheres, or you can call it neurons, and it connects them using you can call it a pipe. For now, it's all the same. Yeah. So it takes a location, x, y, and z coordinates, and then it takes a location n, which is also x, y, and z coordinates. Okay, and I'm not 100% sure. And then we have, okay, so we have this method here, now neurons layer. It creates a layer of neurons, as you see in here, right? This is a layer. We have 2 layers, 1 and 2, and they are fully connected. And the idea is the calculations from so these neurons, the output of these neurons goes to the input of these neurons on the right hand side, and that's why we have these connections. Yeah. Right. And I guess so. I'm just wondering what's the best way to debug this, because obviously I have some extra, they are like extra objects, right? Oh, this is supposed to be like 2 neurons, right? But they're not anywhere to be seen. Don't think so. Okay. So how do I debug this? Chances are it's something that's being returned here. So this method connect layers. So we have the method connect layers. Try and make this a bit bigger for you to see this more easily. Yeah. Let me know if you can't hear me, yeah? You're supposed to be hearing my voice, not just the music. Yesterday I had a little bit of a problem with my sound, and I guess the music is nice, so people didn't really complain. What I'm trying to do just now is just to make sure that the text is a bit bigger, because I want to make sure everyone can clearly read what's on the screen. I know there is some kind of there's like a setting in Blender that allows you to just change like the general size of every single character. Interface. Okay, the resolution scale, yeah? I'm going to make it to 2.0. It might be a bit too big. Hi, Everton. Hi, how are you doing? Yeah, hopefully you're enjoying the afternoon. If it's your afternoon, I don't know. Where are you based? Okay, so this is not too big, I guess. Okay, this is better, right? So you can see, I'm going to try and use all the space available on the screen. Okay, so okay, cool. All right, so let's do, so I have this method, connect neurons, and then have connect layers. Still have more space here. Can use it. And I have, just so for the ones that just joined, right? I have this. This is like 2 layers of neurons. They're supposed to be fully connected, and I have some artifacts here. This looks like chopsticks sideways. They are not supposed to be there, and I need to figure out why they're there and how they're showing up. Okay, so, and this is all Python. Scripting, where is it? I think the letters are so big now that I need to scroll through the top menu. Okay. Right, we have connect layers. Okay, so we have this method that we created yesterday. And oh yeah, and then we also created this additional information. So each neuron layer will have a neuron grid. And I think the easiest way to start our debugging is to just print this NumPy array again. Well, I think I'm already printing actually. So let me just have a look. I want to basically find so oh man, this is too maybe this is too big for me, because now I can't even see. Do I go to the scripting? I think I lost the menu. toolbar? Or I need to navigate through this. Oh, yeah. The scroll up and down. That's what I missed. Okay, so I need to see the console, and that gives me some extra information about what. Okay, I'm going to delete all of this and run my script again. Okay, and I'm going to, where is it? So, script. Okay, I'm going to run it again. We can see this is here again. So I've recreated this, and I have some output here which I wanted to take a look. So I have this neurons grid. And we have some neurons. Okay, so I expect to see coordinates for. So how many neurons do we have? On one layer we have 4 times 4, 16, right? So 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wait, hang on. 4 times 16. So 1, 2, 3. Oh no, I have 16, yeah, okay. So correct. So 16 and then 4 on one side for the other layer. So that seems to be okay. So I'm still not sure. So why is this coming? Unless we're copying something. So connect layers. Okay, so connect neurons. So I'm going through each neuron in layer 1, and then I iterate through each neuron in layer 2, and then I connect both. So connect neurons. Connect neurons. Yeah, as far as I know, this doesn't duplicate anything. Yeah, it's a bit strange. Where is this coming from? Yeah. But they are not exactly in the same position. Okay, they start from here. If I delete this, well, this is how I still see some issues here, right? The self in certain, there's intersections between, but okay, because maybe that's actually interesting. It's creating like the, oh, I don't know how that's happening as well. Why is it intersecting like that? Maybe because there's not enough gap. Yeah, it's interesting. Okay, this is how Blender is dealing with intersections. Because they are not, there's no gaps in between the neurons. I can resolve that later, to be honest. I don't have to worry about that for now. But yeah, of course, this is not nice. How do we solve that? By just having bigger gaps, I guess. Oh. I guess it makes sense, right? It's like it's fully connected. Okay. Right. The geometry is fine. For now, I will just take that. Okay, but I still don't know why the other extra cylinders are there. So how do I make this a little bit? Maybe I could just stop the for loop a bit early so I can see where it goes wrong. So I could do a break, for example, here. Let's do a two breaks. Just to run this and for one cycle. Now let's run it. Okay, so I've done only for one. Just see what happened. And you can see that it's actually good. Yeah. I'm going to delete this again. I'm going to run it for all of them. So so basically I'm going to do all the connections for one neuron. Okay. And see if there is any kind of weird result. You can see it looks good, right? So why does it basically go crazy all of a sudden? Is it because of the collisions, maybe? Okay, let me do the second one. So let's say I'm going to add the counter here, just like to say, okay, index equal to 0, index plus equal 1. Yeah. Okay. All right. So second, I have a visitor. Yeah, sorry. Yeah. Okay, so going back to what we were doing. So I was setting up an index. Right. Okay. All right. So we have the index here, and we have. So if instead of doing a break just on the first neuron, I'm going to say if index equal. This is very rudimentary, right? But you know, I'm just trying to debug this. I'm not trying to write beautiful code at this stage. I'm just seeing what's going on. All right. So index. Okay, let's do this here. So we have. We have here. Now we have two. Whoops. Let me just delete everything that was there before. And let's see. I'll run this again. Save it always. And then see. Oh, there's a script failure. So I must have had some syntax error. Okay. Index plus equal to 1. Oh, because the indenting is wrong. Okay. Okay, so now I'm going to run this again. Let's see. Okay, we have. What is it? Modeling. Okay, this is not. Okay, this is already going wrong. Okay, let me just do this again. And run this one more time. And it should tell me. Okay, so the second. Oh, interesting. Look. These ones are. Oh. Why is it doing the third? Okay, I guess it's doing the third because. Just go back to the script. Just delete it and run again. We have here two nodes. So the first one was fine. Then the second one, it created these two connections, and then the other two kind of didn't work. Just to move this. Oh. We missed two connections from the second neuron. I'm wondering it's because there is intersection between objects. Does it matter? This is not physics, right? Let me see. I'm going to try manually do a rotation of one of these. Rotation, except there's nothing stopping it from rotating. So I don't know what the issue is. Okay. So I'm going to do another test, which is, okay, I know this breaks as soon as you have two fully connected neurons. What if instead of just showing in sequence, I'm going to skip one, yeah? And then the idea is I just see if this is to do with the order or is to do with something more fundamental. So if I'm going to put an if statement here, if index equal to 1, I can still have the break here. A bit ugly, but just trying to see if it has anything to do with the sequence. So let's run again the script. And okay, so I see. So this is actually interesting because okay, now I was able to see that it's to do with the okay, the first neuron was fine. Oh, but the second neuron has some issue there. Huh, why? Unless there's some kind of let me see. Could it be to do with objects being referenced or neuron layer? Okay, are we? Okay. ENQUIRIES. Connect neurons. So connect neurons has some issue. Here. Why is it not actually rotating it? Okay, I'm going to add some debug here. So print into the print rotating. Let's call it cylinder for now. By. Right, so we're going to rotate this by beta and theta. Beta and then theta. I just want to see if the values there are valid or not. PPY the context object. You can see there's 4 cylinders as you expect. I don't know why it failed to rotate the third and the fourth. Maybe this debug will tell me some extra information. Okay, and I'm going to delete all of this again. Rotating cylinder. Oh, I forgot to add something important. It has to be an F string, so it will take these variables. So okay, let's do again reset the objects. So we have Issues? What I can do as well, I can also print the cylinder dot what name. I'm not sure if this is the actual name property, but I'm guessing it will be cylinder dot name. Yeah. So I'm just going to test one. So cylinder dot context or bpy dot context dot object will give me the cylinder. And should I? Okay, name dot name. Okay, so that's correct actually. So I should be able to run the script now, and then so we can see here rotating cylinder 1, right? Then so cylinder is, let's call it 0, then cylinder 1, 2, 3. So these ones that's 3 and 4, they are the ones that are not where I expect them to be. But it does have a rotation, right? So if I look at the code, I see. Like we added an extra 90 degrees or something. If I swapped this, let me just try. Okay, so I have Z, and then I have, oh, okay, this is Y, and this is Z. Oh, where is this printer coming from? Coming from up here. So let me just do one thing. So the Z rotation, I think the Z rotation is correct. I think the Z rotation is correct. It's just the Y rotation is not. Oh. Ah. So it should be like 90 degrees, right? All right, so I fixed it. Fixed it by hand. Okay. Doing so the 2 times pi is actually a 90 degree. Okay, if I go into this code here, so I think it's going wrong. Basically, it's going wrong here in this section. Okay, beta, this one. But I don't think I can take this out. Beta equal to y. Oh. I think this is where it went wrong, because we're not really rotating across. Yeah. Right. Right. So is x equal to 0? Yeah, I'm back. Yeah, sorry, but just right. So I'm dealing here with some issue. Some function is not working properly, and I need to debug it. it's actually, I need to revise some of these mathematics, to be honest. And for modeling, yeah, so this is a problem. So it works for, I guess, for angles there to the right, but then if it's to the, what does that happen anyway? Probably some one of these if statements, right? For this beta, the angle that's going wrong is this one here, theta. Okay, no, theta, no, this one is correct. This one is going wrong. Wow, I'm confused actually. So no, this one is going wrong. If I take this out, let me just copy and paste this. And then remove this extra angle. What do I get? Okay, so this actually makes it worse. What? Okay. Okay, so the rotation that's actually going wrong. So let me just try again. Modeling. The one that's going wrong, this one. Half. Beta. So beta is equal to, let's just, it's not a very scientific way to do it, but it's going to get me there. So let's try, just disable this for now. Yeah. Seems like this is not even being called. Okay, it's called once, twice. think I tried. I think it was Z actually that was the issue. Instead of, okay. So 90 degrees. Why would I rotate it? How does it actually have 180 degrees rotation? That's the question. Beta. Let's see, this is what it is. So it will be negative. So this is location, okay, let's see. This is location 1, and this is location 2. Yeah? So we can see, let's do the object mode, it's easier. So this one is to the left. Because vert is here. So x minus 0.4 and 0.5 for x. I think I'm getting there. Yeah. Right, so this one this is the key. So x print, it's not adding. Weird. Patient. Two and three is going wrong. Rotating the beta and theta. So beta is the first number and theta is the second number. So the first number is the one that's kind of wrong. So beta and theta. Let's see what is going on. These are not exactly. Yeah, I must. All right, yeah. Okay, so so this one is what? Object cylinder. Okay, this is cylinder 2, and this is cylinder 1. So cylinder 3. Oh, it's okay. This one and this one. So 1 and then 3. Okay, so I see. Let's see. 1 and 3. So the rotation that went wrong is here. 1 and then 3. This is actually rotating by like 316 degrees, I think, 360 degrees, so it's actually not doing anything useful. Don't know why it's doing that. Let's do a test. Just remove one of the rotations. Yeah, that kind of is worse. Please we have identified that. So this is radians, right? So math dot. I need to do something. So let's check this. So okay, right. The pi num is 3.14, right? 3.14 is half a circle. Yeah. So it's 90 degrees. 90 degrees angle in degrees, basically. And so what's happening here, this beta is being set here to, well, this if statement says 90 degrees plus this extra angle beta, which can be either, it's probably going to be the tangent. Okay. So actually, maybe this should always be the case. You should always be adding beta. No. So I'm definitely not getting. Okay, it's not right. Oh, because I also removed the rotation, right? Okay, so it's just conditions are slightly wrong. be 90 degrees. So it's adding pi twice. What is that happening? So scripting. So math to pi here. So I can. Beta. So 180 degrees. Oh, so in the 2 and 3, 2, 1 and 0. But before it was something else. Scripting. Hello, hi Pikachu. I'm good, and you? So, I equal to modeling, and we have so this is not actually deterministic, right? No, this is correct. Okay, these ones are correct and these ones are not. So the time it goes wrong is that basically this angle is bigger than 180 degrees. So this is 90 and this is probably going to be already 180. So print f. So beta equal to beta before being macro pi. We have I missed the run brackets. So I'm trying to fix a bug. Yeah, sorry if it's a little bit boring now. I'm just trying to figure out why these two pipes here are not rotating properly. And it's, to be honest, I'm a little bit lost right now, but I think I'll figure it out. I'm just starting it as much debug. So I can see beta is always 0. If it's 0, so if beta is 0, does this? Yeah. Beta is 0. Because x equal to 0. Print. I have to put everything like x equal to x. So this is a vector. Y equal to y and z equal to z. So more debug. And let's just run this again. And I can see now more information. No, not really. I forgot the F here. So let's do this again. Okay, we have x equal to 1, y equal to 10. Okay, so the place where it goes wrong is when x equal to 0. And then the same thing here. Right. Now, how is this x is supposed to be? Okay, let me see. So if I go into modeling, so when this coordinate is it possible? So x equal to here. So it seems like one of these vertices. So x equal to somewhere x equal to 0. No, it doesn't really matter, but it's like so x equal to 0.5. And then it's negative, right? So it's negative x. And then this one is this one is positive. Oh no, it's both positive negatives. Okay, so the same position, so the same coordinates in the x axis, that's causing the problem. So it says if x equal to 0, then beta is equal to 0. But beta doesn't seem to define. Let's see. Don't get it. Okay, let's do this. Think math.py divided by 2. Save it. Oh gosh. I think my Blender crashed again. It's okay. It's not a big deal. You can just start it and start it again. The Blender crashes a lot, so you need to save it. That's why I always do Control S before I even run anything. There's always a chance it will crash. I think I've managed to figure this out. So I'm very hopeful now that I'm going to run this script and it's going to work. I'm very positive. Feeling good. Right. Let's see. Let's do it all of this first. Go to scripting. Just verify this is my fix here. Well, I hope this is my fix. And let's run this again. Fingers crossed. So good. So it was just I think I don't know. It was doing 180 degrees rotation, but actually I needed to just do a 90 degrees rotation. I don't know how that got wrong, but okay. I'm going to enable everything else. There's still some strange things happening here, but you know, I think I've solved the main problem. So during this live stream, I actually added a lot of debug code. Oh, and where did I put that? So okay, so I can just remove I had a for loop. Okay, here. So I've added this myself. I'm going to comment it out for now in case I need it again. I hope not. I know this is working. I can just enjoy the neural network fully connected. Of course, I'll make it prettier, right? This is just a start. Okay, so no, that something went wrong again. So if it kind of failed for the last ones, for the last neurons here. Why? Why did it work for the other ones? Okay, I need to, first of all, scripting. Okay, so we have I'm going to do a break in here, not actual break. It's just a break in a fold. And see if there is a indenting is broken. Let's try again. Oh no, this ran everything actually. Scripting, I must have. Okay, because I'm not doing this. let's do that and run it again. Okay, I've done some progress, right? Okay, although this looks a bit broken, the reason why it looks broken is because there are intersections. Okay, and those issues I'll worry about later. For now, I'm only worried about why the... Okay, so this looks okay. Okay, so maybe I can do index up to 4 and see if this layer is okay. As you can see, there are connections for each node. It's all good. Okay, so let's go back to scripting. And I'm going to increment this by like 3. Let's do 3. So 0, 1, 2, 3. Okay, it goes wrong here. Why? That's a good question. Because I think the position of here, and we can actually check here. So the position for the last one, so beta is negative. So x is negative. This is the first time x is negative, right? No, here is also negative. Oh, okay. For all of those, the last 4 cylinders where x is negative, it doesn't work. Okay, so x is negative because the position of this cylinder here is to the... So because we are doing a vector, right? So the vector we are using position. This is the position of... So we are doing basically the position for this neuron, the location of this neuron minus the location of this neuron. And this neuron, if you look at it, let's just select the object first. Yeah, it has an x of equal 1.5, yeah? And if I just pick a random vertex in the other layer, x is equal to minus 0.5. So this minus the other one, it gives you a negative number, so minus 2, which is what we're seeing the debug. Okay, so that means I can actually just focus on that. So for when x is negative, that it's going wrong. And what should I fix? Yeah, I can actually just do this by, I mean, it's not... I can actually look at the rotation and I can see that the rotation here is set to 5.71. So if I add 90 to this, is it going to work? So 95. Let's see. Oh yeah. So it works, right? So if I add 90 to this as well, so 90, so 101, yeah. Yeah, so that's it, right? So when x is negative, I should be adding 90 as well. Or should I be adding 180? Oh, because beta... Beta is probably negative, right? Of course, and then when we add the two together, it gives a very small positive number. Okay. So x less than 0 and y more than 0. Okay. Da-da-da. I think there's something. Right. So when x is negative, we should be adding. Oh, I see. How did it? Oh. Okay. This is a. I don't know if this is right or not. Okay, so if x equal to 0, beta equal to 0, else beta equal to. Oh, this is not good. I think this code is a little bit. Can be improved for sure. So if x equal to 0, and add the code here. It's not actually. Okay, maybe I just remove this from here. And then have the master pi. I'm doing this right or not. Okay. Okay, like looks okay, right? It's a bit. Okay, we know it's all messed up because of the intersections, but yeah, at least for this layer. So okay. I will need to revise that code because I'm not happy how it's a bit. It's not really mathematics. It's more just like I guess. I'm just guessing. Right. So I'm going to do it this. I'm going to attempt to do the full neural network. And well, not the full neural network, the full fully connected layer. So I'm again going to remove that index. Yeah, so I'm going to comment this out. See. For now, it's okay to just leave that. Wow. Okay, so we have something. So this is working. Okay, of course we have these intersections, but I think if I make this cylinder much thinner, how do we avoid? And I don't know, like I need to also check what is Blender supposed to do with collisions, yeah. So I'm going to check the documentation. Blender. Two objects. I don't know if I make this. If I make the cylinders much thinner, let's try and do that. Just see what happens. It probably will still have intersections, but I'm curious on whether it's going to make any difference. So, where I create the cylinder, specify a radius. So maybe I can just specify 0.01. Let's see how it looks like now. Okay, you can see. Wow. Okay, this is starting to look much more like a neural network, right? Okay. I honestly, I'm not like. I think. Hello. Hi, how are you, Krutik? Yeah, sorry, I just saw your message. If you have any questions, let me know. Okay, so we have something that looks more like a fully connected layer now. It's cool, right? Just have to make it thinner, and then you don't see the intersections that much. Actually, they are there. You can see that they are still there, but it's pretty cool, actually. I'm almost tempted to finish here because this is finishing on a high, but I think I can still do more things, right? Actually, one of the things I really need to do is, because this is not going to scale very well, because I'm actually creating. First of all, I'm using a very inefficient function in Blender. It's an operation that creates this cylinder here, right? And it's actually very inefficient. And if I have like thousands and thousands of connections, this is not going to, it's going to crash. Yeah. So I need to improve this. And I probably want to look at, so I want to look at the more options in array modifier. Okay, we have used the array modifier in Blender for doing things like, in this case, we've repeated this sphere n times using an array modifier. But I think we can also repeat the cylinder using an array modifier. And the thing we do need to do, and this is actually the tricky bit, I need to figure out, okay, I already know the angles, right? Because I'm rotating everything. That method is very, so I could actually pick, basically I can pick like a sphere, and then I can repeat this connection for one neuron. I can repeat it, and the only thing I have to do is change the angle. Okay. We have options. So we have different options in array modifier. Let's see if we can see it from the UI. So let's look at the options in Blender. So we have I don't know why I don't see anything here. Okay, this is the what's this? Thing. We have array modifier. I'm using an array modifier, but I can do it via Python, but I can't find it for some reason in the actual UI. It should be somewhere here. Just want to take a look here. Scene, transform. Actions. Yeah. So force field, rigid body. UV maps. Materials. I think I have to do that in edit object mode, Blender, access, array modifier. So the nice thing about the array modifier, I can change the material. I can change, okay, then total number of copies, an offset, basically a position, which I'm already using this. And I can do rotation if I remember correctly. It's very efficient, and that's why I need to use array modifier, because I have to draw thousands and thousands of neurons and connections between them. I can't just like create create the geometry for each connection. Okay, there's random properties. I don't really like the documentation here because it's not very doesn't have examples. So let's just do a search for Blender, Python, array modifier, rotation. I'm pretty sure there is one. I've already searched for this before. But you know what, like this is a good time to stop, because I've created already a fully connected layer. This is something I just need to scale. I can actually add some more just to see how it behaves, but this is actually very good already. I can already use this as my starting point for the next stream, and I'll probably do a bit more research on array modifiers just to see how how hard I can push it to the limits, right? Because I have to do rotations, I have to do many things to try and get the same result I'm getting now without having to create an object every time. So let me just increase the number of neurons, just see what happens. So I'm going to set, instead of 4, I'm going to make it 16. This might actually crash my computer. We'll see how bad it gets. And then we can do, okay, instead of 2, let's do 4. Okay, it's going to be, this kind of grows exponentially. It's going to be a lot already. You can see Blend is already struggling a bit more. Yeah. Hopefully it doesn't crash. Let's see. Fingers crossed. Hello, hi Ayman. How are you? I'm just running a Blender function that takes a bit longer. All I had to do was to duplicate the number of nodes because it's fully connected layers, so each neuron can connect to all the neurons in the next layer. And then I've duplicated the number of neurons, basically, so that grows exponentially. So that's why I need to, the next live stream, I have to optimize what I've done today so that it can scale across a large number of nodes. I don't know if this one is... yeah, it's always good to end with the Blender crashing. I have to wait. I'm just going to check. Okay, you can see that it's doing something. But it's very inefficient right now. Wow, 2000 for... How many cylinders is it? Hang on. 16 times 16. Oh, that's a lot. Oh yeah, the cylinders is basically the connections between neurons, and it has to create thousands and thousands. That's how complex and neural networks are, and it's actually quite challenging to visualize a neural network because there's so many connections and they can get very convoluted. So the challenge of this project in Blender is to make it really optimal and so that it works at scale. How many cylinders should we have? Let me just think if I can work it out. So 16 times 16 is what? That's a lot of... How did I get to 16 times 16? So 16 times 16. Let's do a calculation to see if I should wait for this to complete or not. So 16 times 16 is equal to 256 neurons. Then we have 4 times 4 is 16. So we have 256 neurons connecting to 4 neurons. No, 16 neurons. I need to do the math for this one second. It's a notepad. So 256 neurons. Layer 1. Okay, all right. Okay, yeah, we're almost finishing, but I'm just trying to work out now like how complex this is, because I've just realized I've picked some really high values and I'm going to crash Blender eventually. So 16 neurons. Yeah, 16 neurons. 16 neurons in layer 2. Okay. So you can imagine each of these 256 neurons has to connect 16 times basically to this one. So 256 times 16. And that's about, I think that's 16. 256 times 16 equal to 4096. Okay, so I should be able to wait for this. So how many cylinders we have? We have about, it's almost finishing actually. All right, so it's completed now. It's a miracle in a bit. Okay, so let's see if this is worth the wait. Wow, look at this. So this is like a fully connected neural network. Okay, it's very inefficient. I'm not happy with this because this is only like a few hundred nodes, right? I need thousands, right? But you know, this is already looking very cool. Yeah. So I think, so the next live stream, I'm going to make this much more efficient than what it is now. I'm going to use the ray modifier to do the rotations and do all things that are needed. All right. Thank you so much for joining this live stream. Don't forget to click the like button and subscribe to the channel if you want to be notified on the next live stream. I should be doing one tomorrow, maybe tomorrow morning. It's going to be a different time. It's going to be probably my evening because I'm in London and I'll have less disruptions because today's Sunday afternoon. There's family time. So I'm going to finish here and I'll see you again soon. Happy coding. By the way, before I forget, I'm going to put this source code again in a gist so you can just try it. Yeah, and yeah. And then you can let me know how it goes. All right.